What if, right now as you're watching this video, your right arm had a consciousness completely independent from you? While you focus on the screen, your right hand could be playing chess by itself, and your left hand could be cooking a meal for you without a single thought from you. Sounds like a sci-fi disaster, right? Actually, this is a summary of one of the biggest engineering and design flaws on our planet. We humans are tied to a central processing unit, meaning that single brain locked inside our skulls. Every pain, every touch, every muscle movement in your body has to travel to that center, be processed there, and return. This means massive data traffic and latency. But at the bottom of the ocean, there is a system that puts physics and modern computer engineering to shame. A main processor and 8 independent subprocessors distributed across its arms. This isn't an alien movie. Meet nature's product of millions of years of R&D, the 9-brained autonomous machine, the Octopus. All the computers, smartphones, and even our own bodies that we use today operate on the logic of a central processing unit, or CPU. When a needle pricks your hand, the signal must travel from your arm to your spinal cord, and from there to your brain. The brain interprets the pain and sends a new signal back for you to pull your hand away. Even though this takes microseconds, in engineering, this is called latency. As the system grows, the load on the central processor increases and the system slows down. But what if, instead of putting the processor in the center and dealing with this traffic, we distributed the brain throughout the entire network? That is exactly what the Octopus does. It's not just an ordinary sea creature. It is a flawlessly functioning distributed computing architecture. An octopus has about 500 million neurons. However, only 1/3 of these cells are located in its main brain inside its head. The massive remaining neural network is distributed across its 8 arms. Each arm has its own memory, its own decision-making authority, and its own autonomous software. The main brain works simply like a CEO or a chief engineer. It sets the target and gives the command, "Catch that crab." But how the crab will be caught, which rock to navigate around, how much each muscle should contract, or exactly where the thousands of suckers on the arm should attach, the main brain couldn't care less. The main brain doesn't waste time with these micro-calculations. Thanks to its own built-in processor, the arm analyzes the environment, touches, tastes, and makes instant decisions completely independent of the main brain. They are so independent, in fact, that if an octopus's arm is severed in a lab setting, that arm will continue to try and hunt, avoid obstacles, and bring food to a mouth that is no longer there, because the software inside the arm is still running. This mechanism isn't just an interesting biological detail, it's the key to one of the biggest technological hurdles humanity is trying to solve today. NASA is experiencing exactly this latency issue with the rovers it sends to Mars. A command sent from Earth takes minutes to reach Mars. When the rover approaches a cliff, having the cameras send the image back to Earth and waiting for the stop command from the central computer creates an impossible data bottleneck. By the time that command arrives, the rover would have already fallen off the cliff. That's why aerospace engineers are trying to embed autonomous decision-making capabilities directly into the rover's wheels and sensors, just like the arms of an octopus. Zero latency, instant reaction, decentralized intelligence. We are currently struggling to mimic with silicon chips an engineering problem that nature solved millions of years ago. Octopuses don't share our evolutionary tree. Our common ancestor with them was a simple, brainless worm that lived millions of years ago. They invented intelligence, consciousness, and problem-solving abilities completely separate from us, starting from scratch in the dark depths of the ocean. They are the true aliens on this planet. The world around us is not filled with randomly formed creatures. It's filled with biological machines, each having solved a different physical and software problem. When you break that visible shell, you notice the massive laboratory underneath. To continue decoding the anatomy of the invisible and unboxing reality, subscribe to Unbox Reality. See you next week.